guys, so today's lesson is on supplementary angles. Supplementary angles are two or more angles that add up to 180 degrees. So in all of the examples that we're going to look at today, we're going to look at angles that when they're lined up next to each other and added together, they'll form a measure of a straight line, which totals 180 degrees. So we know we're working with supplementary angles today because our angles fall on a straight line. So for example 1, we're going to find the missing angle, which in this case is x. Now supplementary angles always sum up to 180 degrees. So we know that if we combine x plus 118, it needs to equal 180. So now I've written an equation to help me find my missing angle. The only thing that connects the 118 to x is addition. So in order for me to isolate x, I need to subtract 118 on both sides. So on the left-hand side of the equation, it cancels out, leaving me with x. And on the right-hand side, I need to calculate 180 minus 118, and that gives me our missing value of 62. So we know that x equals 62 degrees. For example 2, we need to find the missing value. So it's super duper important that for any problem you're doing, you make sure that you answer the question that's being asked. So this question specifically isn't asking us to find either of our unknown angles. It's asking us just to find the missing value. So we're going to solve this for x. Because they're supplementary angles, we know that we have to add these two angles together and set that equal to 180, because the degrees for supplementary angles is that the sum of them is 180 degrees. So because I have multiple like terms in this example, I need to first combine my like terms. So the ones underlined in blue are like terms that have a variable. The ones underlined in green are like terms that are constants. They're just numbers. So 2x plus x is 3x, and then negative 6 plus positive 3 is negative 3, and this needs to equal 180. Now I need to isolate x. So to find my missing value, I need to isolate it. First thing I need to move is the constant. I don't want to touch the term that has the variable in it until the end. That's my last step. So in order to move negative 3, I need to do the inverse operation. So I need to add 3 on both sides. On the left-hand side, it cancels out, leaving 3x. And on the right-hand side, now we have 180 plus 3, which is 183. And then the last step is to completely isolate x. So in order to do that, I need to look at what operation connects 3 to the x, which is multiplication, which means that I'm going to have to do division to isolate x. So I need to divide both sides by 3. On the left-hand side, it cancels out. And on the right-hand side, now we have 180 divided by 3. So x equals 61. And now I can also check that my missing value is correct by plugging it into the angles. So if I substitute 61 for x in angle ABD, 61 plus 3 is 64. And if I substitute it into angle CBA, 2 times 61 minus 6, 2 times 61 is 122 minus 6. That's going to equal 116. Then I know those two need to add up to 180, so let's see if they do. 116 plus 64 equals 180 degrees, so we know our missing value is correct. for example 3, we need to find the missing angle. So in this example, we're going to find angle AOB. These are supplementary angles, so we know that they need to add up to 180 degrees. So I'm going to have to, just like the last problem, combine my like terms in order to find x, but that's not going to be my final answer. But let's do that first. So in this equation that we've created, 7x and 3x are like terms. We're going to combine their coefficients and the variable doesn't change. So 7x plus 3x is 10x, and that needs to equal 180 degrees. And then to isolate x, my final step will be to divide both sides by 10, because the operation connecting 10 to the variable x is multiplication, so we have to do the inverse. It cancels out on the left-hand side, leaving just x. And on the right-hand side, we do 180 divided by 10, which is 18. Now to find angle AOB, we need to plug that missing value into the measure for that angle, which is 3x. So if we substitute that value for x into that expression, we know that angle AOB is supposed to equal 3 times 18. And when we calculate that, 3 times 18 equals 54. So our missing angle is 54 degrees. For this last example, we want to find the missing angle, but this is a special example. In this example, we have 3 angles that form our supplementary angles. And we are just looking for the measure of angle AEB, which is this one here. So we're going to have to add all of these angles together, and the sum of these angles is 180 degrees. So I'm going to go through, I'm going to underline my like terms that have a variable in blue, and my like terms that don't have a variable, which are just the constants, I'm going to underline in green. Now I need to combine these like terms, so 5x plus x plus 3x is 9x, and now I'm going to combine the constants. So 4 minus 2 plus 7 is positive 9. Now all of this needs to equal 180 degrees. Now in order to find x, think about what that first step is that we need to do. We need to isolate the term with the variable, so we have to move that constant first. So because it's plus 9, we're going to have to do minus 9 on both sides. It cancels out on the left, leaving 9x, and on the right, we do 180 minus 9, which is 171. And lastly, we now isolate x. So think about the operation that connects the 9 to the x. It's multiplication, so we have to do the inverse. We need to divide both sides of the equation by 9. On the left-hand side, it cancels out, leaving us with just x. And on the right-hand side of this equation, we now found that x equals 19. But that's not our final answer. Because we're looking for the measure of angle AEB, we need to plug in that value that we just found for x into the expression for AEB. So we know AEB is 5x plus 4. So let's plug in that value that we found for x into this expression. So 5 times 19 plus 4. And that's going to be our answer. So let's simplify this. 5 times 19 is 95. And then when we add 4, 95 plus 4 gives us 99. So 99 degrees is our final answer.